Good morning, learners and all viewers. Welcome to KUTV Elimu Live. My name is Enoch Kasera. Today, I wish to take you through measurement, and the subtopic on the same is surface area. So I want to take you through how you can be able to find the surface area of different figures. That is triangular prism, cube, cuboid, cylinder, half a solid, and a loaf of bread. So make sure that you have a pen, you have a pencil, you have an eraser, and any other writing material. Welcome. Okay, so I want us to start with the triangular prism. So a triangular prism is also referred to as a wedge. So I want us to see how we can be able to find the surface area of triangular prism. Remember, I've said triangular prism is also referred to as the wedge. So we are going to look at the formula. Our formula is area of the cross section times 2, then plus perimeter of the cross section times length. So that is how we are supposed to find the surface area. So the first thing that is very important is for you to understand the formula, and then thereafter we can be able to work it out. So if you look at this triangular prism, we have the triangular part. That is the one that is giving it its name. So the cross section is the triangular part. So to find now the surface area, we are going to find the area of the cross section times 2. The reason why we are multiplying by 2 is because if you look at the cross section, we have two triangles. So we have this one here, and there's also this one here. So we are going to find the area of the triangle, because that is now the cross section. So what do we do? How do you find the area of the triangle? Area of a triangle is equal to a half times base, half times base times height, half times base times height. So after finding that the area of that, remember, half base times height will give you the area of one triangle. So then if you multiply this by 2, you'll find the area of the cross section times 2, the one that is on the other side. And then we again, after finding the area of the triangle, and then we plus the perimeter of the cross section. Now remember, the cross section is a triangle still. So what we do? What we do here, we just add 8, 6, and 10. Now remember, to find the perimeter is the distance all round. So that means that if we are given base as 8 and height as 6, and then we are supposed to find the hypotenuse. How do you find the hypotenuse? We are going to use this formula here, whereby we say hypotenuse is equal to base squared plus height squared, of course, and then we find the square root. So our base is 8. Remember that I've written 10 there. It was not there. So we need to find the hypotenuse. So this is 8 squared minus height squared, which is 6 squared. Plus 6 squared, and then we find the square root. So this one will give us 64. We find the square root. Of course, we add 8 squared, which is 64. 6 squared is 36. So when you add that, what do you get? We find the square root. Of course, now we have 64 plus 36, which is 100. So what is the square root of 100? We get 10. So that means that the height is 10, and that's why I've indicated here 10. So we come here again. Now perimeter of the cross section, remember I've said perimeter is the distance all round. So that means that we are going to take 6 plus 8 plus 10. That is the perimeter of the cross section. Then times the length. What is the length? The length is this one here, which is 12. So this is the length, this one here. So we multiply by 12. We multiply by 12. Okay. So what do we have here? Let's find the area of the triangle. So we have a half times, what is the base of our triangle? 8 times 6. 8 times 6, and then times 2. Okay. All right. So this one is equivalent to, cancel 2 goes here 1, 2 goes here 4. And then now 4 times 6 is 24. 24 times 2 is 28. So 28 is the area of the cross section. Then after that, sorry, this one should be, let me just read this part here. 4 times 6 is 24. 24 times 2 is 48. So we have 48 centimeters squared, and then plus 6. Let's add the perimeter of the cross section. Remember, I've said the cross section is the triangular part. So we add distance all round. Then after adding the distance all round, then we multiply by the length, which is 12. So 6 plus 8, that is 14. 14 plus 10, 24. So we have 24 times 12. 2 times 4 is 8. 2 times 2 is 4. 1 times 4 is 4. 1 times 2 is 2. So what do we have here? We have 288. We have 288. So come and add here 288. Okay. So what do you get? Remember, already we have found the area of the cross section, which is 48. So 48 plus 248. So we can add here 228 plus 48. Okay, so this is 6, 12, 13, carry 1, and then this is 3. So our answer, the surface area of that triangular prism is 336 centimeter squared. So the most important thing here, learners, is you need to understand the formula where we have said to find the area of the triangular prism. Remember, triangular prism is also called wedge. So the surface area is equal to the area of the cross section times 2. The cross section here is the triangle. The reason why we are multiplying by 2 is because we have another one on the other side. So just use the normal formula of finding the area of a triangle, whereby we say area of a triangle is equal to half base times height. So we multiply a half times 8 times 6, then times 2, and then plus the perimeter of the cross section. Now the perimeter of the cross section still remains the triangle. So you again add, and then after adding, then you multiply by 12. So when you do that, you will get 336. Normally, what we do with the surface area, just know that the formula is area of the cross section times 2, then plus perimeter of the cross section times length. So I take you to the next question. The next question. Take you to the next question here. So we have the cylinder. So this is something that you did in class 7. So how do you find the surface area of the cylinder? Now remember, cylinder has got we have 2 types of cylinders. We have the closed cylinder, and also we have the open cylinder. So the closed cylinder has got we have 2 circles and the curved part. So we're supposed to find the area of the 2 circles, and then we find the area of the curved area. So that will give us the surface area of the closed. But when it is open, it means that one of the circles are open. So how do you find the surface area? You only find the area of one circle, and then you add the curved surface area. So let me just take you through that. Okay, so let's find the surface area of this. So the height is 10 centimeters, and the diameter here is 14. The diameter is 14. So our diameter here is 14, okay, centimeters. So just like I've said, we are going to start with the closed. and then I'll be able to explain for you how you can be able to find out the surface area of the open. So normally the formula for the closed cylinder is equal to we have 2 pi r squared plus pi dh, 2 pi r squared plus pi dh. Now why do I say 2 pi r squared? Now remember, I've said when we're finding the surface area, we're supposed to find the areas. Now that this is closed, we're supposed to find the areas of the two circles, and then we find the curved surface area. So the reason why we are multiplying by 2 is because you know how to find the area of a circle. We normally use pi r squared, but because they are two, so we multiply by 2. Okay, so you come here, to take 2 times 22/7 times, what is the radius? Now that the diameter is 14, so radius is going to be 7, because to get the radius we divide the diameter by 2. So it is r squared. R squared means r times r, not r times 2. Many times learners make mistake whereby they just take r and then they multiply by 2. So radius squared means r times r. So we're gonna multiply 7 by 7, and then plus, so this part here, let's bracket this part because of the addition sign. Then pi again, we are now finding the curved surface area. Remember pi dh is the formula of finding the curved surface area. So times 22/7 times the diameter. Now in this case we are not going to use 7, we are going to use 14 because 14 is the diameter, and then times height. What is the height? It is 10 centimeters. Okay, so you come here, let us simplify this. 7 goes here 1, 7 goes here 1. So what are we left with here? 22 times 2. We can put this 2/1 so that you don't get confused. So multiply the numerator and then the denominator. So let's start multiplying the numerator. So we have 2 times 2, which is 44. Then 44 times 7. We can multiply this side. 44 times 7. 28, carry 2. 7 times 4 is 28 plus 2 is 30. So this one alone has given us 308 centimeters squared. Okay, then plus, okay, do the same here, 71, 72. So we have 44 times 10. Of course 22 times 2 is 44. 44 times 10, that will give us 440. Okay, of course this one is also centimeter squared. Okay, equal to, so we are having 308 plus 440. So we can add 440 here, 440. So we get 847. So the surface area is going to be 748 centimeter squared. Always remember the unit. The unit is always very important. So we get 748. So that is how you're supposed to find the surface area of a closed cylinder. So now, how are you supposed to find the surface area of an open cylinder? For the open cylinder, remember, if it is open, it means that one of the circles is not there. So now instead of multiplying by 2, you'll just find the area of one circle. Okay, so we can do it down here. So how do you find? Now this is now for the open, using just the same measurements. So you'll say pi r squared plus pi dh. Okay, so we have 22/7 times radius is just 7 times 7. Let's bracket this. Then plus pi dh, so we have 22/7 times 14 times 10. Okay, so cancel 7 with 7, 7 with 7. What are you left with? You're left with 154. So plus this one already we had worked it out. So what did we get? We get 440. So you just take 154 plus 440. So this is 4, this is 9, this is 5. So the answer here is going to be 594 centimeter squared. So the difference between a closed cylinder, the difference between a closed cylinder and an open cylinder is that a closed cylinder has got two circles. So we find the area of the two circles, and then after finding the area of the two circles, then we find the area of the curved part. And that is why we are using pi dh and then 2 pi r squared. If it is open, then you're supposed to find only the area of one circle, then you add the curved surface area. Okay. Next one. So this is a pipe. Again, how do you find the surface area of a pipe? A pipe looks like a cylinder, but the difference between a cylinder and a pipe is that a pipe has got two hollow ends. So the two ends, this one here and this one here, are hollow. Hollow means that there are no two circles that are covering both ends. So to find now the surface area, you are just going to find the curved surface area. Why? Because there are no circles. So you come here and say surface area is pi dh, just the curved surface area, actually. Curved surface area, curved surface area, curved surface area. That is how to find the surface area of a pipe. So you come here and say, how do you find the curved surface area? Pi dh, pi dh, pi dh. Curved surface area is pi dh. So let us give the measurements. Let's use 20 centimeter as the height, and then you can use 28 as the diameter. Can use 28 as the diameter. Okay, so diameter is 28 centimeters. Okay, so after that, then we can now find the surface area. Remember, I've said to find the surface area of a pipe, because the two circles are not there, it is hollow. So just use the curved surface area. So you take 22/7 times the diameter. Our diameter is 28, and then the height is 20. The height is 20. So what we do next, we can cancel. 7 goes here 1, 7 goes here 4. So you have 22 times 4, that is 88. 88 times 20. 88 times 20, 0, 16, carry 1. 16 plus 1, 17. So our answer becomes 1,760 centimeter squared. So learners, it is important for you to note that when you're finding the surface area of these figures, you need to take into consideration the formulas that I have written there. Now for the pipe, you just need to understand that it is hollow and both sides, both the two ends are open. And so when you're finding the surface area, you're only going to deal with the curved surface area because the two circles are not there. And that's why we are using the formula, which is pi dh, pi dh. I hope that one you have understood it well. Okay, so let me take you to the next example. So we have a cube. A cube is also called square-based prism. Square-based prism. So if you want to find the surface area of a cube, remember a cube has got all sides equal. So for example, if we use 10 here, 10 centimeters, this is also 10 centimeters, this is also 10 centimeters. So I want us to find now the surface area. Now the first thing that you need to know is that just like the other cylinders that I've just discussed, cube, we have a closed cube and we also have an open cube. Now normally a cube has got 6 faces. So to find the surface area of a cube, you're supposed to find the area of all the 6 faces. Now remember, the faces of a cube are made of squares. So that means that when you are finding the area of a cube, you're supposed to find area of each square, and then you multiply by 6. That is if it's closed. But when it is open, it will depend which side is open. But for a cube, there's no problem. So you just find the area of each square and then you multiply by 5. Remember, when it's open, the faces are going to be only 5. But when it's closed, the faces are always 6. So because it is a square, just multiply side by side, because that is how we are supposed to find the area of a square, side times side. And then after that, then you multiply by the total number of faces, which is 6. So you multiply by 6, you multiply side by side, and then times 6 if it is closed. And then again, you multiply 5 times 5, side times side, times 5 if it is open. So let's do one example here for you to be able to understand it well. Okay, so I've used 10 here. So closed, we're starting with closed. So all I've said there are 6 faces. So, and I've said each face is a square. So to find the surface area, we say side times side, then times 6. This is closed. This is closed. This one is closed. Okay, this is closed. Side times 6. So just take 10 times 10, then you multiply by 6. Why 6? Because there are 6 faces. So 10 times 10 is 100. 100 times 6 is 600 centimeters squared. So that is how you're supposed to find now the surface area of a closed cube. Now, what about if it is open? What about if it is open? If it is open, then we just we have explained earlier that an open cube has got 5 faces. So we just come here and say surface area is equal to 5 times side times side. 5 times side times side. 5 times side times side. So we have 5 times side times side. 5 times side times side. So just take 5 times the measurement of each side is 10. So you multiply 10 times 10 is 100. 100 times 5 is 500 centimeter squared. It's important you indicate the unit. So that is actually the difference between a square, a cube and a cube. An open cube and a closed cube. I've said a closed cube has 6 faces. So you find the area of each face. So remember, each face is made of a square. So you just find the area of a square, whereby you multiply side by side, then you multiply by 6. And then if it is an open cube, then you multiply side times side, and then times 5. Okay. The next one is a cuboid. So for a cuboid, again, just like I had explained, for a cuboid has got 6 faces if it is closed, and an open one has got 5 faces. So remember, cuboid is made up of rectangle. So we find the area of the rectangle. After finding the area of the rectangle, then we multiply by the number of faces. If it is closed, we're going to multiply by 6. But if it's open, we're going to multiply if it is closed, then that means that there are 6 faces. Then when it's open, then it means that there are 5 faces. So let me just take you through the examples so that you can be able to understand it better. Okay, so we have a cuboid here. We can give the measurements. So this can be 10 centimeters, and then this is 2 centimeters, and then this one is 3 centimeters. 3 centimeters. We can use 5 centimeters. Okay. So we are starting with the closed. So for the closed, remember this one is length, this one is length, this one is width, and then we have this one is height. This one is height. So we are going to find the area of each face, which is made of rectangle, and then we add them all. Now it is important to indicate all the the measurement of each side. So this is 5, this is 10 centimeters, this is also 10 centimeters. Of course, here is going to be 5 centimeters, and then this one is 2 centimeters. Then we find the area of each face. Okay, so according to the formula that I've just written here, for the closed, so you take 2 into bracket, length times width. So we have this face here, the face that is facing us here. We have 10 and 5. Those are the measurement of this face here, this one here. So we have the measurement as 10 and 5. So that is what I want us to multiply. 10 times 5. Then plus. We also have length times width. So the length is this one here. Or we can use the bottom part, whereby we have 10 and 2. So the measurement of the rectangle that is found at the bottom, its measurements include 10 times 10 and 2. So you again take that 10. Let me erase this here. So we have 10 times 2, 10 times 2, and then we have this one here, this one which is on this side. So what is the measurement of this one? 5 and 2. So again you add 5, then times 2. 5 times 2. Now remember these 2. Okay, you are supposed to multiply all this by 2. So since if we start with 10 by 5, the measurement, this is this side here, this triangle here, we have 10 and 5. And remember, there's also another rectangle on the other side. So you take 10 times 5 and then times 2, because there are two rectangles. And then if you look at this, the measurements of 10 by 2, this is the lower part. So the lower part, we have the bottom part and the top part. So that's why we are taking 10 times 2 and then we multiply by 2. And then we have this side here. The measurement of this rectangle here is 2 and 5. So remember there are 2 of them. So that's why I've taken 5 times 2, then times 2. So let's work out that. 10 times 5 is 50. 50 times 2 is 100. Plus 10 times 2 is 20. 20 times 2 is 40. Plus 5 times 2 is 10. 10 times 2 is 20. Okay. Then we add. So 100 plus 40 is 140. 140 plus 20 is 160 centimeters squared. So the most important thing here is for you to be able to understand that if you're working out the surface area of a cuboid, you're supposed to understand that a cuboid has got 6 faces. That is if it's closed. So then again, it is important to understand that cuboid is made of rectangles. So you need to find the area of each rectangle, which will form the face, and then after that, then you add all the faces. And that's why if you look at my first measurement here, we had 10 and 5. So I identify 10 and 5, which is this one here. So 10 and 5, we have 10 and 5. So we multiply 10 times 5, and because there is also another one on the other side, you times by 2. Plus, again, we have the measurement, that is the bottom part, 10 by 2. So the top part is also 10 by 2. So you take 10 times 2, then you multiply by 2, because there is also another one on the other side. And then finally, we have this one here. So this one is also a rectangle with measurement 5 and 2. So when you find the area of this, and then you multiply by 2, you'll have worked out the area of those 2 rectangles. So that is how you're supposed to find the area of a closed cuboid. Now, what about if it is open? Now, when it is open, it will depend which side is open. So you might find that this side is open, or the top part is open, or this side is open, or even this side is open. So it depends. So what you need to do is to identify which side is open, and then you also identify the measurement of the side that is open. That one will help you to understand how you will be able to work out that given question correctly. So you need to identify which side is open, and then identify the measurement of the side that is open, and then now you work it out. So we can work out this here. Okay, so we have let me just draw a line over here to separate this. Now we have an open cuboid. Now, like I've said, it is important for you to identify which side is open. So many times learners assume that the top part is the one that will always be open. That's not the case. Sometimes, like you can see here, I want to use this side as the open one, and then after that, then we work it out. Now, that side that I've just indicated using the arrow, we want to assume that that is the side that is open. So we have to identify the measurement of that side, and the measurement is 5 and 2. So you will have to remember, when you will be multiplying, you will have to remember which side is open, and so that you don't multiply by 2. Remember, when one side is open, it means that the other side is not open. So all the remaining sides, you'll find the normal area, whereby you just say length times width times 2. You'll multiply by 2. Then when you will be working out the side that is open, you'll remember to multiply by 1, because one side is the one that is open. So you come here. Okay, so we have 2. Let's start with the bottom part. So the bottom part, the measurement of the bottom part, we'll multiply by 2. So we have 20. 2. This should be 2. Let me erase this one here. Okay, so we are starting with the bottom part. So the measurement of the bottom part is 10 by 2. So we multiply 10 times 2. Okay, so this will give us what? That is 20. 20 times 2 is 40. We are done with the bottom part. Remember, I've said never assume that it's only the top part that will always be open. Any part of this cuboid can be open. So remember, the part that I've indicated that is open is on the side, and the measurement of that side is 5 by 2. So when we'll be multiplying 5 by 2, let's just multiply that. 5 by 2, you don't again multiply by 2. Now the reason why the dimensions of this side is 5 by 2. So 5 times 2, then we multiply by 1. You don't multiply by 2. Reason, the other side, this side is open. So this one will just give us 10. And then finally, we have this side here, 10 by 5. So we have this one here, 10 by 5. Remember, there are 2 of them. So 2 times 10 times 5. Okay, so 10 times 5 is 50. 50 times 2. 50 times 2 is 100. So now when we add 40 plus 10, we get 50. 50 plus 100 is 150. 150 centimeter squared. 150 centimeter squared. So learners, it is important to identify which side is open. And then, like I said earlier, to find the area of a cuboid, you need to identify the measurements of each side. Remember, a cuboid is made up of rectangles. So you find the area of each rectangle. After finding the area of each rectangle, then you add all of them together. Okay, let me take you through the next example. The next example. Okay, so we have a cylinder. Now I want to really emphasize on this. To find the area of our cylinder, which is also referred to as trough, and we also have the one that is referred to as a solid, half a solid. So we are supposed to differentiate the two. I've said we have alpha cylinder, which is the trough, alpha cylinder, which is the trough, and then we have what we call solid, alpha solid. Now the difference is that with the trough, remember, the inner part is always hollow. That means that there is a hole. And then for the alpha solid, this is just like a piece of wood that is cylindrical in shape, and then you cut it at the middle. So when you cut half a log at the middle, you'll get two half solids, and you realize that given figure is not going to be hollow. So to find their surface area, they have got two different formulas, and this is just what I want to show you here. So we will start with half a cylinder. So this is a trough, and the bottom part is, the inner part is hollow. So let me just indicate for you. So this part here is hollow. That means that, a trough can be used to feed animals. So then you put your feeds inside here. So this part here that I've just indicated there using the arrow is hollow. So how do you find the surface area? Now the surface area is equal to area of the cross section times 2, then plus circumference times length. Circumference times length. Now there's also another thing there that I really need to emphasize on. That is the difference between circumference of a semicircle and perimeter of a semicircle. Now circumference, remember, circumference, you just find the curved part, you don't add the diameter. So to find the circumference of a semicircle, we are going to use the formula half pi r squared, half pi r squared. To find the circumference of a semicircle, sorry for that, you just say half pi d, half pi d. That is how you're supposed to find the circumference of a semicircle. Let me just repeat that. To find the circumference of a semicircle, you just say half pi d, half pi d. But to find the perimeter of a semicircle, remember perimeter is the distance all round, So what do? You just say perimeter of a semicircle is equal to half pi d plus d. So you add the diameter. But for the circumference, you just say half pi d. You don't add the diameter. So looking at this now, that's why we have there the surface area is equal to the area of the cross section times 2, and then plus circumference times length. So I want to use the first formula because it is always the easiest. So you come here, you say surface area is equal to area of the cross section. Now our cross section here is this one here. This one is the cross section. So the cross section is a half a circle. So how do you find the area of half a circle? How do you find the area of half a circle? So area is equal to pi r squared. And because there are 2, so you'll multiply by 2. That's why we have area of the cross section times 2. If you like, again, you can just combine the 2 semicircles, and then you find the area of one circle. So just say pi r squared. But let's just use this because according to the formula we have indicated area of the cross section times 2. So the cross section is half a circle. So we use half pi r squared. Remember, it is area of the cross section. Then times 2, because there is also another one on this side. We also have another one on the other side. Then plus the circumference times length. Now, the circumference is the circumference of the cross section. So how do you find the circumference? Like I indicated earlier, to find the circumference of a semicircle, you use half pi d, then times length. What is the length? The length is this line here. This line here is the length. So according to this, our example here, the length is 20 meters. So you then multiply by 20. Okay, now you will find that when we'll be finding the surface area of the solid, we'll use perimeter of the cross section, But in this case, if it is you are finding the surface area of the trough, we are using circumference of the cross section. So you come here. Let's now try to work it out. So we have half times 22/7 times, what is the radius? the diameter is 14. The diameter is 14. So radius is 7. Then times 7. Remember, I've said r squared means r times r. So again, don't forget to multiply by 2 because there are 2 semicircles. 2 goes here 1, 2 goes here 11, 7 goes here 1, 7 goes here 1. So we have 77 times 2. So 77 times 2, this is 14, carry 1, 154. So this is 154. And then come here again, plus half times 22 over 7, 22 over 7, 22 over 7, let me bring it up, 22 over 7, then times, what is the diameter? What is the diameter? The diameter is 14, so use 14, then times 20, which is the length. Okay. All right, so 2 goes here 1, 2 goes here 11, 7 goes here 1, 7 goes here 2. So what do you have? You have 22. You have 22 times 20. 22 times 20. So this is just like 220 times 2. 0, 4, 4. So 440. So add here 400 and what? And 40. Because now that is the area of that is what we get when we multiply circumference times length. Okay, so you have 154, you add to 440. So what do you get? 495. 594 meters squared. So learners, it is important you know the formula. The formula is very simple. To find the surface area of a trough, you just have to find the area of the cross-section times 2, because there are 2, and then you add the circumference of the cross-section times length. I am really insisting on that because I find that many times learners forget. It is circumference times length. Circumference times length. That is if you're finding the surface area of a trough. But now, when you'll be finding the circumference of, when you'll be finding the surface area of a solid which is not hollow, we are going to use the formula cross-section area times 2, then plus the perimeter of the cross-section times length. So in that case, we are going to use the perimeter. Remember, our cross-section is a half a circle, and so if it is half a circle, for the first one, for the trough, we were using the circumference, but now for the solid, we are going to use perimeter. Okay. So we just okay. So we just come here. Okay. All right. That's great. Okay. The next page. Okay, just a minute. Shift the pages. A minute, look at the page. All right, there we are. So we have the solids. Now this is the solid one. So we are going just to use the same measurements, but now here we are going to find the surface area of the half cylinder, solid half cylinder. Remember, I've said now the top part is not hollow. So this part here is not hollow. Not hollow. Not hollow means there's no space over there. So the top part, remember, it is rectangular in shape, and so there's no hole inside. So how do you find the surface area of this? I'll use the first formula, whereby we say the surface area is equal to area of the cross section times 2. So area of the cross section times 2. Our cross section is not hollow. All right, so we come here. What is area of the cross section times 2? So area of cross section times 2, like I've indicated there. Then plus perimeter of the cross section times length. Okay, so Let me not use this part because I've already written it there. It's no need. Let's just come and work it out. So surface area is equal to area of the cross section. So the cross section is a half circle. So how do you find the area of half a circle? Half pi r squared times 2. Okay. Then plus perimeter of the cross section. So how do you find the perimeter of the cross section? Remember, the cross section is a semicircle. So I have pi d plus d, then times length. What is the length? The length is 20. Okay, so you come here and say we have half times 22 over 7 times, what is the radius? The radius is 7 times 7. Remember, it is times 2. So because there are 2 of them, and then plus a half times pi is 22 over 7, then times the diameter is 14, and then plus diameter, which is 14, and then times 20, which is the length. Now, when we are finding the surface area of the half a cylinder, which is the trough, we said we don't use the perimeter. But now in this case, we are supposed to use perimeter because this part here is not hollow. Okay, so you come here, let's simplify this. 22 goes there, 2 goes there, 1, 2 goes there, 11, 7, 1, 7, 1. So you have, this is 77 times 2. 77 times 2, that is 154. So we have 154. 154 meters squared. And then plus 2 goes here 1, 2 goes here 11. 7 goes here 1, 7 goes here 2. So 22 plus 14. 22 plus 14. Remember, we are finding the perimeter. So 6, 3. So that will give us 36. So now we have 36, then we multiply by 20. Remember, I've said here use the perimeter. So after finding the perimeter, then you multiply by the length, which is 20. So we have 154 plus 36 times 20. 36 times 20, 0, 2, carry 1, 720. So, and then after finding the, after working it out like that, then you add. So we have 720 plus 154. So what will this give us? This one will give us 874 meters squared. So the difference between the two is that with the trough, you use, on the other side you use circumference of the cross section times length, but if it is a solid, you use perimeter of the cross section times length. Okay. The next example here is we have a loaf of bread. So this is also another area that is very important for you to understand. So for a loaf of bread, the cross section is made up of a semicircle and a rectangle. So that means that if you are going to find the area of the cross section, you're going to multiply, or to find the area of each cross section. That is, we are going to find the area of the semicircle, and then also we find the area of the rectangle. After finding those two areas, we add them. So that will give us the area of the cross section. Remember, after adding, there's also a semicircle on the other end and a rectangle. So after finding the area of the semicircle and the rectangle, we multiply by 2 because there is also one on the other side. That will give you the area, the area of the cross section. And then now you'll be coming to find the perimeter of the cross section, you are going to find the distance all round. So you just find the curved part of the circle, the semicircle. So you'll use the formula half pi d, and then you find the straight lines on the rectangle. So let me just take you there so that you can be able to understand it well. Okay, so like I was saying, we have this part here, which is the cross section. According to the formula, area of the cross section times 2. then plus the perimeter of the cross-section times length. So for us to find now the area of the cross-section, remember our cross-section is this part here, which is made up of two figures. We have the semicircle and also we have the rectangle here. So for us to find the area of this part here, we are going to find the area of the semicircle and then we find the area of the rectangle. The answer that we get, we add. After adding, then we multiply by 2. Okay, so you can start doing that. So the cross-section, we start with the cross-section area. I've said that our cross-section is made up of a semicircle. We have the semicircle, and also we have, so we find the area of the semicircle, and then area of the rectangle, So we can do that. How do you find the area of the semicircle? Half pi r squared, and then plus rectangle. How do you find the area of the rectangle? Length times width. Then remember, after finding the areas of those two, you multiply by 2 because there is also one on the other end. Okay, so you come here and say we have half times 22 over 7, half times 22 over 7, half times 22 over 7. Okay, half times 22 over 7. Okay, times what is the radius? If the diameter is 14, so now this 14 here, which is the one of the left side of the rectangle, is the diameter of this semicircle. So the radius is 7 times 7. Okay, then plus length times width. The measurement of this rectangle is 14 by 5. So you just take 14 times 5. Of course, let's bracket this to follow. Then after finishing, then you multiply by 2. You multiply by 2 because there is also the same figures on the other side. So 2 goes here 1, 2 goes here 11, 7 1, 7 1. So that one is 77. Okay, so 77 plus 77 plus 14 times 5, 14 times 5, it should be 70. Okay, now you add here 70. So we add the 2. So we have 77 plus 70, 147. So you have 147. Then you multiply by 2 because there are 2. So this is 14, carry 1. 8, 9, and then 2. So that one has given us 294. 294. Okay, so 294 is now the area of the cross section. The area of the cross section. Okay, so now after that, the area of the cross section. Okay. So we have now found the area of the cross section. So I want us to move to the next part, which is finding the perimeter of the cross section. Finding the area, the perimeter of the cross section, because according to the formula we have the cross section area times 2. Okay, we have the cross section area times 2. The cross section area times 2. Okay, and then the cross section area times 2 plus the perimeter of the cross section times length. So let's find the perimeter of the cross section. So perimeter, how do you find the perimeter of the cross section? Perimeter of the cross section is made up of this part here. So we have the semicircle and we have the semicircle and we have the rectangle. So just add the lengths. So we are going to add 14 plus 5. Remember there's also 5 here. So 14 plus 5 plus 5. This is equivalent to 24. And then now we find the circumference of this semicircle. How do you find the circumference? Circumference is equal to half pi d, So what will we have? Okay. So we're gonna have half times 22/7 times the diameter, which is 14. So 7 goes here 1, 7 goes here 2, 2 goes here 1, 2 goes here 11. So 11 times 2 is 22. So now the 22 has given us this part here, which is the curved. So 22. So let us add 22 plus the 24 that we had after finding the measurement, the measurement of the length and the width. So what do we get here? 24 times 2. Okay, so 24 times 2, 24 plus 22, this is 46. 46. Okay, so now 46, we add to this one here, 46. So 294 plus 46, So this is 0, carry 1, 14, carry 1, 3. So our final answer will be 340. Okay, just a minute. There's something here I've forgotten. This part here. Just a minute here. Now this 46 is the perimeter of the perimeter of the cross section, which is here. So the perimeter of the cross section is 46. So now this 46 we are supposed to multiply by the length. Sorry for that. So we have before we add, remember this one had given us, this one here had given us 294. So we come here. The perimeter of this cross section is 46. According to the formula, we are supposed to multiply perimeter of the cross section times length. So we have 46 times what was the length? The length is 20. So 46 times 20, 0, 12 carry 1, so 2 carry 1, 8 plus 1 is 9. Okay, so that one now has given us now the perimeter of the cross section times length. So you add 920. So when you add 294 plus 920, what do you get? So let's add here 294. So this is 4, this is 1, carry 1, 11, 12. So our answer here is going to be 1,214 centimeters squared. So actually, what you need to do is to find the area of the cross section times 2. And remember the cross section here, we have the semicircle and the rectangle. Then you multiply by 2. After that, you also find the perimeter of the cross section. So to find the perimeter, you just add the length, the width. We have 5 and 5, then 14. Now you are not supposed to add this 14 that is at the middle here. That 14, you should not add it because perimeter is the distance all round. So if you are to go around this figure, you will walk just round it without going into the middle. So, and that's why I've just added 5 plus 14 plus 5, and then I found the circumference of the semicircle. The answer that I got, I multiplied by the length, and then I added to the area of the cross section. So we can move the next page. All right, so we have KCP questions on the subtopic, and we have different years. So if you see there, we have 2010. So there was a question on number 48, and this one was asking about half solid cylinder. So half a solid cylinder, I said you use area of the cross section, then times 2, then perimeter of the cross section times the perimeter of the cross section times length. Okay, in 2011, the question was on number 29. So we had a cylindrical rod. I'll take you through that. So cylindrical rod is just like a cylinder. So you just find the surface area of a closed cylinder. Now in 2012, the question was on number 39. So it was about combined shape. So we had a cube and a cylindrical rod. 2013, the question was on number 41, whereby we had the curved surface. Remember, curved surface, you're supposed to use pi dh. And then 2014, the question was on number 25. So number 25, the question was about area painted, and then it was a cylinder. Then 2015, it was number 26. So in number 26, you are asked to find the radius, and you are asked to find the radius, and you are given the curved surface area. And then in 2016, it was on number 23. This is 2016, it was number 43, and this was a half solid cylinder. So this half solid cylinder, you're supposed to find the surface area. Remember the formula, surface area of half a solid is equal to cross section area times 2, then plus perimeter of the cross section times length. And then finally in 2017, the question was number 4, and this was asking about a closed cylinder. This was asking about a closed cylinder. So that is actually how those questions were set. And so okay. And now I want just to do one question. This one, KCPA, this was 2012 number 39. So 2012 number 39. So the question was, the diagram below represents a metal solid made up of a cylindrical bar fixed onto a cube. The cylindrical bar is 20 centimeters long and has a diameter of 7 centimeters. Each side of the cube is 9 centimeters long. The surface of the solid was painted. What area in centimeters square was painted? Now remember, if we are finding the surface area, the area that is painted, then we are supposed to make sure that we find the area of all sides that are outside. Now remember, this metal rod is fixed on the top part of this cube, and so to find the area of the top part of this cube, we are going to find the area, and then after finding the area, and then we subtract the area of the circle. So what do we do here? First, let us find the surface area of the cube. So how do you find the surface area of the cube? Surface area of a cube is equal to side times 6. But because the top part is there is a metal rod fixed, so we are going to use only 5 sides, whereby we are going to say side times 5. So the side here is 9 times 9 times 5. So what will this gives us? We have 81. We have 81 times 5. So 540. So this is 405. So 405 is now the 5 sides excluding the top part. Now remember, we are supposed also to find the area of the top part. Now how do you find the area of the top part? The top part is fixed a metal rod. So what do? We just find the area of the top part, which is square. So we take 9 times 9, Then subtract area of the circle, which is a half pi r squared. So 9 times 9 is 81 minus a half times 22 over 7 times radius. So what is the radius? 7 over 2 times 7 over 2. 7, 1, 7, 1, 2, 1, 2 here, 11, 2, 1, oh, sorry. So what do we have? We have 77. We have 77. Okay. So just a minute. 81 minus a half times 22 over 7. Just do it again. What is the radius? The diameter is 7, so the radius is 7 over 2 times 7 over 2. 2, 1, 2, 11, 7, 1, 7, 1. So what do we have there? We have 77 divided by 4. 77 divided by 4. So what do we, when we simplify that, what do we get? Okay. All right. Sorry, this shouldn't be that. Half. So we have 7, 1, 7, 1. And then 2 here, 1, 2 here, 11. Sorry for that. So what do we have? We have now 81 minus, now 11 times 7 is 77. 77 divided by 2 is 36.5. 36.5. 36.5. Okay. So 81, let's subtract that. 81 minus 36.5. What do you get? So this is 5. This is remaining 0, so 4. Okay, this was 7, 4. So we have 44.5. So that 44.5 is now the area of the top part. So that area of the top part, we add it because it is part of the cube. So we add to 405 to find out the area of the cube, the surface area of the cube. So we have 405, then plus 44.5. What will this give us? We'll have here, when we add, okay, so when we add here, we'll get 5, 9, 4, 4. So we have 449.5. Now that is now the one for the cube. And then after that, then we also find the surface area of the, now of the cylinder. Now the cylinder is open because there is this part that has entered the cube. So how do you find the surface area? We just use pi r squared plus pi dh. So already we have found the area of the circle, which was, what is the area of the circle? The area of the circle here was 36.5. So we just write that 36.5 here, 36.5. So the area of the circle is 36.5. Then now plus pi dh. So 22 over 7 times the diameter is 7, then times 20, which is the length of the cylinder. So 7 goes here 1, 7 goes here 1. So this is 440. So we take 3, 36.5 plus 440. What do we get? 5, 6, 7, 4. 476.5. 476.5. Now that 476.5 is now the surface area of the cylinder. So we come again here and add it here. 476.5. So 0, 9 plus 6 is 15 plus 1, 16 carry 1, 11, 12 carry 1, and then carry 1. So the answer is 926.0. Okay, so I want you guys, I believe now I've been able to help you. So I want you to do number 25, and then you submit the answer that you will get. I want to end from there because our time has really gone. I want want to end from there because our time has really gone, so that you can be able to do this one question that is remaining. Okay. Then okay, so what I want you to do, that one question that I've just left for you, please make sure that you do it and then you submit. I hope by now you can be able to find the surface area of different solids, starting from triangular prism, cube, cuboids, solids, and half a solid, that is, and all the cylinders. So what you just need to do is just to understand the formula, and then from there you can be able to work it out. Now for the half a solid, I said circumference, the area of half a solid is equal to, surface area of half a solid is equal to area of the cross section times 2, and then plus perimeter of the cross section times length. So when you do that, you can be able to get the correct answer. Now I want to take this opportunity to thank you all for watching. I believe now you are able to go. Make sure that you do a lot of practice. Mathematics needs a lot of practice. And so if you practice more, you'll be able to understand more. Until next time, thank you very much. Bye-bye. God bless you all.